Okay, so for this bell work, there's one wrong answer in particular that I understand. Anyways, I'm going to kind of run through the way that I would approach this. And so we've got this room, whatever it is, this floor. And I know it's 15 feet wide, and I'm going to put 15 feet right here. And this is 21 feet long. Now, knowing that there are 3 feet in a yard, what I want to do is I just want to divide this. I want to figure out how many yards long and yards wide this room is. So if this is 15 feet, well, 15 divided by 3, sorry, is 5. So it's 5 yards in width. 21 divided by 3 is 7. So that means it's 7 yards long. So if the very first thing I do, if I just kind of draw a diagram, drawing a diagram is always a helpful thing to do. And then if I do the conversion at the beginning, now I can see it's 7 yards by 5 yards. Now when I multiply the length times the width, I get 35 yards squared in the middle. And that's my answer. So what some people did, and there were a number of people who answered D, and this one I can understand why people did that, because here's what happens if you got D as your answer. You did your 21 times 15. 21 times 15 is 315. And what you did is you divided by 3, because you did the same thing. You're like, oh, there's 3 yards or 3 feet in a yard, so I'll just divide by 3. Oh, there we go, it's 105. Except the problem, the reason that doesn't work is because if you're talking about square yards, there are 3 feet by 3 feet. There are 9 square feet in a yard. So we've got 2 dimensions. It's actually 3 squared is 9 square feet in a square yard. So we'd have to do not this, we'd have to do 315 divided by 9, which is a fine thing to do if you understand that, and you'll get 35 as a result. Okay, and that's 35 square yards. All right, so we've got, we're going to look at compositions today. And right now that's not going to make tons of sense, but this will make, you don't know what those are yet, but it's actually, I will tell you at the beginning that you basically already have all the knowledge that you need based on what we did last week. And we will look at that in more detail in a minute. But the first thing I wanted to say, because this applies to some of you in this room, in the Zoom chat, there are some of you who have not been doing your homework. And these homeworks that I've been assigning are due this Thursday, 2 days from today. So I want to encourage everyone to get those done. And if you have never signed up for Delta Math, that is not an excuse. All right, I keep saying every day, if you haven't signed up for Delta Math, stick around, I'll help you get signed up. That's still the case. If you have not signed up for Delta Math, you will get a 0 for not having done any of the work there. You can't say, oh, but I never signed up. Sorry, you've had plenty of opportunities to do that. Okay, so I wanted to show you what an assignment looks like in Canvas so that when you go to this Canvas classroom, you know what you need to do. Okay, so it's hopefully very, very obvious here that all these that are indented, and that's what I always do. Anytime there's something that you need to do to turn in for credit, I make it indented off to the side, and it even says the word assignment. And you'll see that you have 9 of them right now. I'm going to get into student view real quick. So it looks exactly like what you would see, except formatted a little differently for iPad. But anyways, you can see 9 assignments. So for most of these, if I click on this one, all it's going to tell you to do is go over to Delta Math and do this assignment. And you can see every single one of them has said in the name itself and in the assignment, it says it's due January 21st, which is Thursday. So this is not something that's just snuck up on you. It's been announced over and over and over again. All right. For today's homework, it's going to be a little different, and I will explain that one when we get to it. So make sure you're getting that done. I don't know that I need to say more right now, but I will come back to the Canvas page. Okay, and Thursday is going to be your first test. It's going to cover everything that we've done so far, but the primary focus is going to be on transformations and specifically those coordinate rules. So there's not going to be a whole lot of stuff where it's on the graph and you have a triangle here and like, oh, where does this triangle end up? It's not going to be questions like that to a large extent. Instead, I'm going to give you a coordinate. I'm going to say coordinate A is at 1, 5, and you do some stuff to it, dot, dot, dot. Where does it end up? Where's A prime? And you're gonna have to tell me what the coordinate is. Okay. So now moving ahead, we're looking at compositions. So this language that I'm about to use might not mean anything to you, but it'll make perfect sense, it should, when we do some examples. All right, so a composition, I could just summarize it, say it's a sequence of transformations. We're going to do multiple transformations in a row. That's what a composition is. Pretty straightforward idea. Now, when you do the first transformation, the output, the image that you get from the first transformation becomes the pre-image for the next one. So we don't start at the same spot every time. We keep doing a transformation, taking that output, and then doing a transformation to that, taking that output, doing a transformation to that. And you could theoretically just keep doing transformations forever, but you don't need to. And at most, you'd only need to use 3 transformations. Okay, so now let's look at this. First of all, I want to start with a triangle of some sort. Okay, we've got a triangle. I want to label it also A, B, and C. Okay, so the very first thing says reflect over the x-axis. Not a big deal. I will do that. So this is going to be A prime gets reflected right here, B prime gets reflected right here, and C prime gets reflected right here. And I'm not going to go through in detail how I do that. If you don't know how to do a reflection, then you can watch the video on that part of it. We did that last Monday, I believe. Okay, so there's a reflection over the x-axis. And now we're doing a transformation or a composition. So I'm going to take this output, C prime, A prime, B prime, C prime, and I actually want to do another transformation to it. I want to rotate this 90 degrees counterclockwise. So I want this triangle right here to rotate 90 degrees counterclockwise, which is that way. And we don't do rotations like this. And if we were in class, we would. But as it is right now, we're not really doing rotations on a graph. So I'll just do this real quick. This is going to end up right here. That one's going to be there. That one's going to be there. So this triangle right here. Now I'm going to go through examples where we just focus on the coordinates in a little bit, but I just want to show you what's happening. What's the word I'm looking for? I just want to show you what's happening graphically, visually. All right, so this is A prime. That's C. Oh, and this is the other thing. When you do another transformation, it's not just A prime anymore because we already have an A prime. This is A double prime. So this is going to be C double prime, and this is going to be B double prime. And so we can do triple prime, quadruple prime, just add another kind of apostrophe, another tick to it. All right, and this composition is just 2 steps. And so we're done. Now the question is, what is the coordinate for B prime? So B double prime. If this was on your test, then I might give you this, and then you'd have to do a transformation here, transformation there. B double prime is at -1, 2, 3, 4, 5, 6, +1, 2. B double prime, the coordinates are -6, 2. So I'm only asking for 1 coordinate in this case. I could ask for all 3, but that's not what's happening here. We're going to do another composition. So I want the first point to be here, the second one to be here, and the third one to be here. So A, B, C. And this is my starting image, so I'm just going to go ahead and draw it with solid lines. Okay, so that's what I'm starting with. Let's see what my composition tells me to do. The first thing is to translate up 3. 1, 2, 3, and left 4. 1, 2, 3, 4. So I don't want to, I'm not going to go into all the details on this, but you can follow the mouse as I'm moving it along. So there's A prime. I can do the same thing for all of them. Up 1, 2, 3, left 1, 2, 3, 4. There's C prime. All right, and for B, up 1, 2, 3, left 1, 2, 3, 4. That is B prime. Okay, so we just translated it. What are we going to do next? Now we're going to reflect over y equals negative x. This is one of those lines I told you you need to have memorized. I don't know what more to do for that, but you just need to practice, okay? So y equals negative x is actually a diagonal line that cuts through like so. All right, I'm going to call it good right there and there. So I did it this way intentionally because A prime happens to be right on the line. When a point is right on the line, and I didn't show you this in class, but it's probably exactly what you imagine. When a point is right on the line and I reflect it, it stays exactly where it's at. It's no distance away, so it doesn't move anywhere. So A prime will actually also be A double prime. B, on the other hand, I can see is, if I count with the mouse, it's 1, 2 diagonals away. So I'm going to go 1, 2 diagonals away on this side. And there's B prime, B double prime, I'm sorry. And then C prime is right here. It's 1 away. So I'm going to go 1 on the other side. And this right here is C double prime. All right, so I can connect these together. All right, and you can see if I just focus on this triangle and this triangle, it looks like a reflection. All right, just double checking, make sure that everything looks good. And I believe it does. Okay, so that's the second transformation. The last one is rotate 90 degrees clockwise. And I'm using this triangle right here to rotate 90 degrees clockwise. So I'm going to go this way. Okay, so let me do that. So this point is going to end up here. We would normally use our coordinate rules for this, so I'm just going to do it pretty quickly. This one's going to be right here. And then this one is going to be at right there. So when I rotate, I end up with A triple prime right here, B triple prime right here, and C triple prime right here. So this is my final figure. And what's the coordinate for A triple prime? It looks like it's going to be at 5, 5. So if I count over from the origin, it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There it is, 5, 5. Okay, now let's get to what your test will primarily be. There might be a little bit of visual stuff on the test, but for the most part, it's actually going to be using our coordinate rules. And I will also, really quickly, get out of this and go over here so I can bring this up. This is what you're going to want to refer to. Hopefully you guys have been referring to it and you've been doing your work, but we are using these coordinate rules. So you do not have to have these memorized. If it tells you to do a 90-degree clockwise rotation, well, you just come over here and you look at it. I'm going to use that rule. So if you don't know how to use these rules, if this is like looking at a foreign language, well, you need to go back and watch those videos where we explained these, okay? So I'm just going to pick these rules and apply them. And let's see what that looks like in practice. Okay, let me get past this real quick. Now, I've got compositions with coordinate rules, and I've got 3 coordinates. I'm actually not going to do all 3. I'm going to do 2 of these, and it should make sense, and you'd know how to apply the third. So the first thing I want to do, actually, let me look at the entire composition. I believe this is just a 2-step composition. And so I'm going to rotate 180 degrees and then reflect over the y-axis. Okay, so let me kind of show what's happening here. I want to convert this into a coordinate rule. Rotating 180 degrees, I go to my reference sheet. I say, what is the coordinate rule for rotating 180 degrees? And I see it's this one right here. Okay, and that's it. I just copied that rule. I don't have to have it memorized. I just saw when you rotate 180 degrees, this is what happens to your coordinate. Very good. And then I'm going to reflect over the y-axis. I'm going to bring this down a little bit. What is that coordinate rule? Well, I take my starting coordinate and I do this, negative x, y. A pretty simple rule. And I copied it down. That's good. All right, now here's what we do with our coordinate. I'm going to go ahead and use 4, 1 for my input coordinate. So the first thing I want to do is rotate it 180 degrees, which means I'm going to use my first coordinate rule. C of 4, 1 means, well, I just take my input. Remember, you take your x and you just plug it in for x. So this is going to be negative 4 and negative 1, which, I mean, you don't have to do it in 2 steps. That's negative 4, negative 1. This is A prime. And at this point, this negative 4, 1 becomes my input for the next transformation. So now I'm going to do y of negative 4, negative 1. I don't use this anymore. I've already used it. So I only use the negative 4, negative 1. Okay, so now I can plug this in. So it's going to be negative. This negative 4 gets plugged in for x. So that's going to be negative, negative 4. Negative 1 gets plugged in for y. So it looks like that. So my final coordinate after this transformation is over, after this composition, is going to be 4, negative 1. This is a double prime, and this is my final answer. Okay. Hopefully that's pretty straightforward and you're following along with it. So let's do this one more time for another coordinate. All right. So we are still using the same coordinate rules, but now I'm going to input negative 3, negative 5 in. So I start with a 180 degree rotation of negative 3, negative 5. And when I plug that in, the negative 3 gets plugged in for x, the negative 5 gets plugged in for y, so it's negative, negative 3, and negative, negative 5, which becomes positive 3, positive 5. This becomes my input for the next coordinate rule. So y of positive 3, positive 5. And this gets plugged in, so it's negative 3, 5. So I just took the 3 and plugged it in for x, the 5 plugged it in for y, and I end up with that, which, just to write it nicely, it's negative 3, 5. And this is, B double prime. This one right here is B prime. But then I did another transformation to it, made it B double prime. Hopefully you're following along and this is making sense. Okay. Again, if you're getting lost in some of these other kind of more foundational skills, like how you use these coordinate rules, then again, you've maybe not been paying attention the last couple of weeks, and you need to go back and watch some videos to get caught up. Hey, why don't you raise your hand? Let me know you're paying attention. Okay, same thing as before. These coordinates actually haven't changed, but now we have a new composition. So now we have 3 steps to do. I can translate, I can reflect, I can rotate. So let's kind of run through this one by one. The translation is a little bit more work, and we're going to see in a second. I'm going to show you your homework tonight, and some of it will actually be made a little easier. It says translate down 4 and right 2. Now, your translation rule looks like this: x plus h, y plus k, and that's all it tells you. Well, now you need to kind of put this in context. If it's asking me to go down 4, that's telling me to go -4 in the y direction. So it's not y plus k, it's actually going to be y minus 4. And then it tells me to go right 2. Well, that's +2 in the x direction. So it's not x plus h, it's actually going to be x plus 2. That's my translation formula. You do need to be aware of how to do that. Okay, so now I've got t of xy. All right, I'm not going to plug anything in yet. I want to get all my functions set up. All my functions and coordinate rule, those are kind of interchangeable terms. And so I'll kind of use them both, but the coordinate rule is the function. Okay, so the next coordinate rule we're using is reflecting over y equals x. So this coordinate rule looks like this. And when I reflect over y equals x, I get yx as my output. And then lastly, I get this, which is rotate 270 degrees counterclockwise. But if I look at my coordinate rule reference sheet, we don't have that one. So I need to remember that 270 degrees counterclockwise is the same as 90 degrees clockwise. So 90 degrees clockwise and 270 degrees counterclockwise are the same. And I know that rule. This is going to be this rule right here, which is going to be y negative x. And again, you don't have to have it memorized. If you don't know where that rule, if you don't have that rule memorized, which I doubt anyone does, that's fine. As long as you know that I got it from that reference sheet, you can go back and double check me. And you can go back and double check yourself. So anyways, let's just do this for A and B. I'll start with A. So I'm going to do t of 4, 1. That's going to be 4 plus 2, 1 minus 4. Notice I plugged the x and the y in for their respective values. So I'm going to get 6, negative 3. Now I'm going to take this. This is A prime. I'm going to plug that into the next function, next coordinate rule. P of 6, negative 3. All I'm doing here is it says xy becomes yx. All it's telling me to do is flip my coordinates. So my output here is negative 3, 6. Very straightforward. That's A double prime. And I'm going to take that and plug it into the next one. So this is going to be R of negative 3, 6. And this is telling me to flip my coordinates again. Notice I go from xy to yx. And if you forget, just you're plugging this negative 3 in for x right here, and the 6 is getting plugged in for y. So 6 comes up to the front, and it's going to be negative 3, which becomes 6, 3. And that's A triple prime. This is your actual final answer. Okay. I'm going to do just one more of these, and then I'm going to show you something on your homework. And if you want to go through more because you don't understand, I encourage you to stick around and we can do that. Let me just clear some space here. All right. So now we're going to use this. That should still be a y right there. All right, let me plug this point in. T of negative 3, negative 5 becomes, I'm going to plug negative 3 in for x, negative 5 in for y. So negative 3 plus 2, negative 5 minus 4. All right, we need to know how to do this. So negative 3 plus 2 is going to be negative 1. Negative 5 minus 4 is negative 9. So I'm going to plug that is B prime. Plug that in for the next one. P of negative 1, negative 9. All I do is flip the order, and this becomes negative 9, negative 1. This is B double prime. I'm going to take negative 9, negative 1, plug it into the next. R of negative 9, negative 1 is, well, let's see, when I flip it, I bring the y up to the front, so it's just going to be -1. And -9 gets plugged in for x right here, so it's going to be -9, which becomes -1, +9 as my final coordinate for A triple prime. Sorry, I said A. B triple prime. Okay, sorry for that confusion. Okay, hopefully that's good. And like I said, I can go through many more of these if you guys need me to. Not everyone does, so I'm just gonna show you what your homework looks like, because this homework is a little different. All right, let me go back to modules. Again, these are all the rules. It's on the Unit 1 section of this Canvas page. It's down at the very bottom. But your assignment today is in Canvas. And this is a little different. Notice it says right here, you're gonna click Submit Assignment. No. And it says type in the answer to number 2 and number 3. And I wanted to explain what I mean when it says type in the answer to number 2 and number 3, because here's your actual assignment. And you've got 6 problems here. Let me get back. So there are 6 problems on this, but you don't have to turn in all 6 of them. You just need to do problems 2 and 3 in order to get credit for this. And it says ignore the last part of every question. So if I look at this, every last one of them says write an algebraic rule. Don't worry about that part. So ignore that. And when I say put your answer, I only care about the very last coordinate. So you're going to end up with a coordinate for A triple prime. You're going to end up with a coordinate for B triple prime. And you're going to end up with a coordinate for C triple prime. So down here, let's say that this was problem number 2 and I found my answer. I would just say, okay, so for problem number 2, A triple prime is 1, 1. B triple prime is 4, 3. And C triple prime, no, obviously I'm making these numbers up. -7, -5. Okay, so that's all I need to type. That's the only thing you need to show me. And if you are good to go, if you feel like you understand how to do the homework and everything else, that's good. The last thing I'll say is that I do recommend you do all 6 of the problems, but just turn in 2 and 3. Okay, if you want to go through another one of these problems, you can feel free to stick around. If you feel like you've understood all of this, then you can have a wonderful day. I will see you tomorrow when we will review for the test.